Welcome to Kigali-Engineers-College.
It's caught in the crossfire. It's caught.
But we shall try our best. So I got here red and black. You know, orange is red and black. Orange is positive and then black is negative. But here we have to first of all see if this connected, whether how they are, we can get the correct direction of the motor. So we have to put this black onto negative pin and this red onto the positive pin. Now the motor is running and the motor is bringing the air out of the engine. So we have to first, rather than to reverse parts and say, if I do this one and then put black here and then put red here, what do I do now? Now the air is coming into the engine, cooling our engine systems. Okay, thank you so much. Dear followers of the Kigali-Engineers-College, and by names of Joseph Milishema, I'm going to be with you today on the lesson about the cooling system of the engine. As you can see, last time we talked about what we call, you were given a lecture about the overview of the engine, but obviously, as you know, the engine has a lot of subsystems, whereas we have to include what we call the cooling system, not forgetting what we call the lubrication, and also what we call the exhaust system, and also what we can call air. We can say like it's air, intake, and then we have to see the fuel supply system. But then we have to focus on what we call the engine cooling system, as I can say. First of all, we know that the engine cooling is just as an application system for internal combustion engines. For this regards to the engine temperature, whereby you cannot reduce the temperature of the engine without this cooling system, because as you know, this prevents the engine from overheating, what we call excess heating, or heating can cause components to warp. When I say warp, this is like components can be like too large and then seize. People, you know, when a piston reaches what you call the cooling system, you know, the piston becomes very large, it expands because of due to heat. And then after expanding, then it shall have to seize and then the movement of the engine is cracked. Then from there, we have to say that the engine, some of the components have to fail. Like, as I've been saying, you know, if the engine is not working very well, you know, the cylinders will not actually move as they're supposed to move. So from there, we have to know what we call the main components of the cooling system. We have seen that we have here we have the fan of the cooling system. As you know, the fan is one of the best things we have to understand about. Then we have to say that the fan helps to draw air through the radiator, and we have different kinds of fans. Here we have a mechanical fan, which is driven by the engine, as you can see here. You can see that it's not driven electrically or automatically, it's just the engine is driven. And then we have here, as you can see, so we have what we call this is an electric fan. But most of the times also we have an automatic fan, you know, which uses the, like what we call thermometer switch. So from there, we can see that most of the times no system operates without battery. So we have the battery here for the power supply, for the fan to operate, and then we have what we call the coolant. That means in the plant we have the antifreeze and a mixture of coolant and water. So from there we have the coolant offer tank, which is an expansion tank, which is given here. The storage of water, excess water that comes from the radiator. And then from here we have the coolant hoses. Here we have the upper and the lower hoses. As you can see, we have the radiator here. And obviously from there we have what we call the radiator. As I was saying, that we have the radiator here. As you can see, we have different types of radiators. We have cross-flow radiator, which is this one having the side tanks. Tanks the sides of the radiator. And then we have what we call the downflow radiator, which has the tanks on the longitudinal side. Whereas the downflow has the tanks on the vertical side of the radiator. And we have the tubular thing and we have the plate where we have not have them to show you to them today. So, but obviously, another kind of component we have to see is about the coolant. Now we have to understand what is the coolant ratio, what is the coolant mixture. Now we have the burnt ratio always, it has to be 50-50, the 50 of the antifreeze and the 50 of the water. And then or it might be, the mixture might be 60-40, or it might be all 30-70 depending on your wish. But minimum is 30-70 and maximum is 40-60. So you have to now mix your blood before mixing, and we have to understand about this. And besides that, we have the thermostat. One of the main components of the cooling system was this opens depending on the engine temperature. Whereas the water, when it is still hot and the engine is not at temperature, then this has to open around the temperature to pass. Then it has to compress when it is hot, allow the fluid passing up to the radiator. And from there, we have what we call the radiator pressure cap. This is the pressure cap, which is always on the radiator here. At the top of the radiator, when it's showing us how to fill the radiator, this also maintains the pressure of the system in our vehicle or systems. So from there, let's see what's next. Then we have to see about what we call the radiator pressure kit, which comprises a lot of things that can be used to test the system of our vehicle. I mean the system of the cleaning system, by the way, where we have this hand pump, and we have here the adapters, and so depending on the type of radiator, depending on the type of pressure cap we have, we can test the system efficiently. And from there, we have what we can call the digital multimeter for testing the current within the battery or testing the systems so as to see whether there is a kind of shortage of current or any kind of external resistance. We have the spanners, this is a screw, fast screw, we have the plier, we have different kinds of spanners to see whether our systems are not operating efficiently. But before that, we have to first understand the operation of our fan. How does our fan operate? What is the relation of the fan and the cooling system? First of all, from the point of view of the engine while in front of the engine, it has to be going what we call clockwise direction, because it has to suck the air outside from the engine to the radiator. For example, let me say like we have here our radiator, and maybe I'm in front of the engine side, and then I have the fan. It has to go what you call clockwise direction. This is the fan. That's the rotation of the fan. If it goes anti-clockwise, it will be sucking the air from the engine instead to outside the atmosphere, causing the engine to overheat, as you can see. And then from there, I jumped about two types of cooling systems. We have air and liquid cooling system. Obviously, I think someone will talk about this in the but maybe when we say air cooling systems, always using on two-stroke engines. When we say liquid cooling, it's using on first-stroke engines, whereby we use liquid as a coolant. And in this one, we use air as a cooling system, whereby we have the fins here, and here we have the radiator, and other systems, and we have the pump. So, now we're going to see about how we can install our radiator, fan, and also how we can test our pressure caps to see if they really function as we have to say. Most of the times I say that these caps will usually operate between 15 to 16 psi. You know, when I say psi is pound per square inch. When we say like the normal range of the cap is just between 15 to 16 psi. When I say psi, this is the normal range of this radiator pressure cap. So now, before we go ahead, I'm going to say about a simple circuit on how we can install this motor of the radiator fan. So here we have a circuit. Here we have a motor, and this motor is a DC one. And then here we have what we call the control line. We have this is like a switch, and then we have a battery. And we have battery ones sometimes we do like this. Some of them do it like this, others do it this way. Now here we have negative, then we have what we call positive, which is connected here. And then the negative comes back to the motor. So for the motor operation, we have to first of all turn on this. When I turn on this, the motor should go this way, or it might come this way, depending on your way of installation. This is how to do it. But remember that most of the time, the motor has to go what we call clockwise direction. Not anti-clockwise. So, we go by installation of the motor. But first of all, testing the battery to see if it has the current it should be having before just doing anything else. So, you have to turn my digital multimeter into what we call direct current, not AC current, because we're using a battery. But if you're using a kind of this AC current, you have to use what you call testing in AC current. So we have to test, first of all, we have to set a multimeter, and we see the current of the battery, then we test. Based on our tests, on our testing, we shall find the battery has 14.15, and then if you reverse batteries, you have to find what we call the negative 14.14. So now the battery is capable of running our fan. So what do we do then? We have to first then let's see what our motor, what our fan runs like. Let's first of all test for the battery and see if it goes into the right direction. First of all, I put the red here, and then I say, let me show you just a simple way, and the motor is going to be, this is our regulator, and then this is the motor. I'm going to try to see if it operates really as it's supposed to be operating. So, what do we do then? Let's do it this way, and then we shall have to bring, you see already here, it's here as a ready button, as a ready adapter, to be adapted to our, it's very not easy to adapt it here to make it stand, but we shall try our best. So, I got here red and black. Always red and black, always red is positive and red black is negative. But here, we have to first of all see if this connecting whether how they are, we can get the correct direction of the motor. So we have to put this black onto negative pin and this red onto the positive pin. Now the motor is running, but the motor is bringing the air out of the engine. So we have to first, rather than to reverse that and say, if I do this one and then put black here and then put red here, all the way to that. Now the air is coming into the engine, cooling our engine system. So we're going to talk about now. From the fundamental, we'll talk about what we call pressure cap, whereby I say that first of all, it operates between the range of 15 to 16 psi. But before then, we're going to test and see if this can make it out, or this one can make it out. So here we have a pressure cap tester, which is universal. It contains adapters, as you can see, and also some of the more. And then we have here the hand pump with its gauge for indication, and then we have what we call the pipe of 4 horsepower of air. Then we have what we call the compressor. This will also allow the air to go out of this hand pump, as you can see, as you can hear. So then I have to first of all pick one of these. Then it is this one, and then we have to see if it really fits on its adapter. Now we shall try to see. Now I fix it on the you can see now it can fit on this adapter very well and fluently. And then from there we have to catch up this one for them to mesh together. And then after meshing them together, we shall have to join this hand pump to see whether when placed they can fit. Now we have to first adjust. We have to first adjust this. Now we start adjusting for it to contract and then catch up on what I want to touch. As you can see, I'll try to fix it here and then try to make it down. When it reaches its end point, then you can hear while you're trying to do this. And then as you can see now it is fixed very fluently. Then I have to test and see if really you can get the pressure I'm supposed to be having on this pressure cap. So I have to pull down slowly and then I have to compress. As you can see, when I'm compressing, there isn't any change within the pressure gauge. Now as you can see, there is no changes. So we have what you call the leakage within our pressure cap radiator. So now this indicates that pressure in the system is not really at the maximum range. We have to do what? What we have to do is to replace this pressure cap so as for the system to operate fluently. So thank you so much.